Every angler has lived this moment. The boat arrives at a promising cove before sunrise. The water is glass smooth. Conditions are perfect. The first cast lands. Nothing. The second cast, nothing. The frustrating part is not that the fish did not bite. The frustrating part is that the fish were already gone. They vanished before the boat stopped moving. This video is going to explain why. The answer comes from a sensory system that evolved 400 million years ago that every freshwater predator possesses, and that most anglers have never even heard of. This is real science. The system is called the lateral line. Visible as a faint row of pores running along each side of a fish from the head to the tail, the lateral line is often described by biologists as a sixth sense. It is not hearing. It is not vision. It is not smell. It is a mechanical detection system that allows freshwater predators to feel the shape of the water around them. Researchers call it touch at a distance. Every object moving through water creates pressure waves. Those waves travel outward in all directions, carrying information about the size, speed, direction, and identity of whatever produced them. The lateral line reads those waves the way human skin reads temperature, instantly, continuously, without the fish needing to think about it. The receiver is a tiny organ called a neuromast. Each neuromast contains a cluster of hair cells covered by a flexible jelly cap. When water pressure bends the cap, the hair cells generate a nerve signal to the brain. A single largemouth can have over 4,000 of these neuromasts distributed across its body. Every one of them is reporting water movement at the same time. The sensitivity is the part that matters to every angler. Laboratory studies published in peer-reviewed fisheries journals have documented that free neuromasts respond to water current changes as small as 3/100ths of a millimeter per second. That is slower than the speed of a snail. The fish detects it. The fish locates it. The fish decides whether it is prey, predator, or threat. A fishing boat moving across a lake produces a hydrodynamic signature that the lateral line reads like a signature on paper. The hull displaces water. The trolling motor propeller creates vortices. The wake rolls outward in a characteristic V pattern. Research published in the Journal of the Acoustical Society of America documented that these vortex signatures persist in the water for several meters behind the source. That means the freshwater predator holding on a point does not need to see the boat. It does not need to hear the boat. It reads the wake. It reads the propeller turbulence. It reads the pressure differential of the hull. By the time the anchor drops, the fish in a 40-foot radius have already processed that signal and moved. And here is the biological reason the response is so fast. The lateral line is the evolutionary ancestor of the inner ear in every vertebrate species on Earth. It predates eyes by tens of millions of years. It predates scales. It predates jaws. For 400 million years, the signal a predator reads as incoming threat has been wired directly into the survival reflex. The response is not learned. It is engraved. Here is where the science gets specific and actionable. The lateral line is most sensitive to frequencies below 100 Hz. That is the range of low-frequency mechanical vibrations. Boat hull slap, foot taps on an aluminum deck, a trolling motor head rotating, tackle being dropped. All of these fall inside the 100 Hz window. All of these light up the lateral line like a flare. Above 100 Hz, the fish auditory system takes over, processing sound waves traveling through water. Below 100 Hz is lateral line territory. Lateral line territory is where every angler loses fish without knowing it. Your normal speaking voice is mostly above 100 Hz. That is why fish do not spook from talking. But the clunk of a heavy reel being placed down, the drop of a rod butt on a deck, those are below 100 Hz. Those broadcast. The distance this broadcast travels is the part anglers most underestimate. Research studies published in zoological journals have documented that the lateral line can detect wake vortices from other moving fish at several meters. A boat hull and a trolling motor produce hydrodynamic signatures many times larger than a single swimming fish. The effective warning radius for a predator detecting an approaching fishing boat is not measured in feet. It is measured in tens of feet. This is why the first cast of the day matters so much. Not because the fish are more hungry at first light. They probably are, but because the first cast into a cove is the only cast made before the lateral line signature of the boat has fully reached every predator in the area. Within 3 to 5 minutes of anchoring, every fish within casting range has been notified. Before the rest of this video reveals the 7 specific behaviors that broadcast the loudest signal, point your camera at the code on the screen. The angler's vault just opened with the full stealth approach protocol, the distance and decibel thresholds for each activity, and the exact sequence that tournament pros use to approach a spot without triggering lateral line detection. The vault includes the Reading the Water module, the annual calendar of predator sensitivity by water temperature, and the complete behavioral reference for stealth approach in all conditions. Link is pinned to the top of the description. One-time payment, no subscription. Now back to the science. Number 7 on the list of lateral line broadcasts, the trolling motor. Specifically, a trolling motor run at high speed in shallow water. The propeller generates a vortex street that trails behind the boat for several meters. That vortex street falls inside the lateral line detection window for every freshwater predator in the area. High-speed motor use in water under 10 feet deep is the single largest detectable signal most anglers generate. The fix is speed reduction. Trolling motor efficiency drops sharply above 40% throttle in shallow water because the propeller begins to cavitate. Cavitation creates microbubbles that amplify the vortex signature. Running the motor at 20 to 30% throttle reduces cavitation, reduces the wake signature, and cuts detection distance by a measurable margin. Number 6. The anchor drop. Every angler has dropped an anchor into shallow water. The impact creates a low-frequency pressure pulse that travels outward through the water column. The splash above the surface is the visible part. The pressure wave below the surface is the part the lateral line reads. A single loud anchor drop in a quiet cove signals threat to every predator within 40 feet. The protocol used by tournament anglers is a controlled lower rather than a drop. Feeding the anchor rope through the hands until the weight touches bottom eliminates the impact pulse. The water displacement is spread across several seconds instead of concentrated into a single spike. Predators in the area register the event as gradual flow, not as threat. Number 5. Any hard impact on the boat deck, dropped tackle, rod butts hitting fiberglass, metal tools striking the casting platform. Every one of these impacts generates a mechanical vibration that transfers through the hull into the water below. Aluminum boats transmit these frequencies more efficiently than fiberglass. Fiberglass boats transmit more than wooden boats. The lateral line reads this as a predator landing nearby or as another large fish crashing into structure. Either interpretation triggers retreat behavior. A single heavy tackle box being set down on a hard deck surface can spook predators across a 30-foot radius. The fix is a rubber deck mat or tackle tray liner. The additional material absorbs impact and breaks the mechanical transmission from deck to hull to water. Number 4 is a signal most anglers have never considered: the drag of the fishing line through the water. Monofilament and fluorocarbon lines create friction vortices as they cut through the water column. Those vortices are small. They are also continuous. A line being stripped across the surface for a long retrieve generates a persistent low-frequency signature that the lateral line reads as sustained movement. Line diameter is the largest variable. Thicker line creates larger vortices. 15-pound test monofilament generates roughly double the hydrodynamic signature of 8-pound test. On pressured water where predators have learned to associate line vortices with danger, dropping line diameter from 15 to 8 or 10-pound test can produce measurable strike rate improvements. The physics is straightforward. Smaller line equals smaller wake. Number 3. The cast itself. A lure hitting the water is an impact event. The splash signals a foreign object arriving in the water column. For a brief window of time, predators interpret this as either a prey event or a threat event. Large, splashy lures arriving aggressively in shallow water tip that interpretation toward threat. Small, quiet lures entering with minimal impact tip it toward prey. The fix is casting form. An overhead cast delivers the lure with maximum velocity and maximum impact. A sidearm pitch delivers the same lure with a flatter trajectory and a softer entry. On clear, shallow water, tournament anglers use underhand pitches specifically to control entry sound. The entry can be reduced by tenfold with proper form. Number 2 on the list is hull slap, the rhythmic smack of waves against the side of a boat when anchored in wind. Every slap generates a pressure pulse. A boat anchored perpendicular to the wave direction receives a slap every second to 2 seconds. That frequency, roughly 1/2 to 1 Hz, falls squarely inside the lateral line detection window. The fix is boat orientation. Anchoring the boat parallel to the wave direction, bow into the waves channels the water along the hull rather than against it. The rhythmic slap disappears. Field reports from tournament anglers on windy days consistently show that boats oriented bow to the wind produce better results than boats oriented sideways to the wind, even when both are fishing the same structure. Number 1 on the list is the broadcast that never turns off. Human footsteps on a boat deck. Every step transmits a low-frequency mechanical pulse from the hull into the water. The frequency depends on body weight, walking cadence, and deck material, but it consistently falls between 2 and 10 Hz. That is deep inside lateral line territory. Every footstep is read, every shift in weight, every crouch. Research on how fish respond to repeated pressure pulses has documented that the freshwater species native to most North American lakes abandon a location after 3 to 5 consecutive pulses, that is 3 to 5 footsteps, after which the spot is cold until the pulses stop and enough time passes for residual detection memory to fade. The fix is the most important protocol in this entire video. Move less. When you must move, move slowly. Rubber-soled footwear absorbs impact. Padded deck mats dampen transmission. Crouching down while moving reduces weight transfer. Stopping completely between casts allows lateral line signatures to dissipate before the next event occurs. On pressured water, anglers who move at 1/3 the speed of average anglers routinely catch twice as many fish. The 7 broadcasts: trolling motor hum, anchor drop, deck noise, line drag, cast impact, hull slap, and the constant footstep pulse. Every one of these signals is detected by every freshwater predator within a measurable radius. Every one of them reduces your strike rate. Every one of them is controllable with a specific technique. The compound effect is what matters. Individual fixes produce small gains. Applied together, the improvement multiplies. Stealth approach protocols used by tournament anglers in high-pressure fisheries have documented strike rate improvements between 20 and 40% across a tournament season. The physics is simple. The fish that did not know you arrived is the fish that hits your first cast. The tournament anglers who win major events on pressured water share one consistent behavior. They prepare their approach before they prepare their lure. They position the boat quietly. They set up tackle without clatter. They move across the deck once they are in position, and they do not move again until the cast is in the air. The lateral line gives every angler a choice: broadcast your arrival or do not. The complete stealth approach protocol, the 7 broadcast fixes with distance and decibel specifications, the water depth modifiers, and the behavioral adjustments for pressured versus unpressured waters all live in the angler's vault. The Reading the Water module covers the full science of how predators sense their environment. Link is pinned to the top of the description. Hit the like button if this changed how you think about arriving at a fishing spot. Drop a comment with which of the 7 broadcasts you know you have been guilty of. The next video in this series builds from the comments. 400 million years of evolution gave every predator in the water a warning system. Now you know how it works.